In example 6, they want us to find y prime for the equation y times e to the x equals 3 times pi. Well, so first of all, y prime is equal to dy dx. So I'm going to use the dy dx notation in here, and this is what we're going to be looking for. Let's start with our equation. Y times e to the x is equal to 3 times pi. And we will differentiate using the product rule. So the first times the derivative of the second, so d dx of e to the x, plus the second times the derivative of the first is equal to the derivative with respect to x of 3 pi. So this is the first time I've done this. I've used d dx as a notation for take the derivative of this. So at this point, I have not yet taken a derivative, but what I have done is I've laid out this entire equation so that I know where to take a derivative and where not to take a derivative. And so for complicated functions, or maybe functions that aren't as easy for you to think about, like a product of e to the x and some other variable, it might be good to just go ahead and lay out your product rule before you start taking the derivative. This keeps you from having to think about too many things at one time, and just kind of take this one step at a time. So now all I have to think about in this first term is, now what is the derivative of e to the x? And so the derivative of e to the x is actually just e to the x. Now we have to apply our chain rule here, and so that means that I'm going to have y times e to the x, and the derivative of x is dx dx. So that would just be 1. So now we have e to the x times, and the derivative with respect to x of y is just simply dy dx. And that's going to be equal to the derivative with respect to x of 3 pi. There's no x there, so it's a constant, and the derivative is 0. I want to solve this for dy dx. So let me go ahead and subtract y e to the x from both sides. And I have e to the x dy dx is equal to negative y e to the x. Now we can divide both sides by e to the x. E to the x is canceled. Dy dx is equal to negative y. And that is our y prime.